Before we start with wave calculations, let's take a look at a few important things we need to know first. There are two important things in a wave that we need to know: the frequency of a wave and the period of a wave. The other is closely related: the period. This is the time it takes for one complete cycle or wave to pass a point, measured in seconds, s. They are related to each other by a simple equation. You'll notice that they are the inverse of one another. Frequency is 1 over period, and period is 1 over frequency. If I know frequency, I can work out period. If I know period, I can work out frequency. Please remember frequency is a lowercase f and period is a capital letter T. Just like everything else we have been dealing with, waves have to travel at a certain time, and that gives us a wave speed or velocity. Wave speed is the distance that a wave covers in 1 second. Many things can affect the speed or velocity of the wave, like the density of the material, how elastic it is, and even how wide or deep the substance is. You might have remembered that sound travels much faster through water. That brings us to the wave equation. So, the first part is velocity is equal to change in position divided by change in time, written as v equals delta x over delta t. This is what we use if we want to measure the distance and time. But the wavelength and the frequency wave is quite important, which gets us to this very important equation, which is known as the wave equation. Where v is the speed measured in meters per second, f is the frequency which we know is measured in hertz, and lambda, which is the symbol to the right. This is the wavelength, and that's measured in meters. Often with waves, we prefer to use the wave equation because we refer to frequency and wavelength more than anything. As with any equation in physics, make sure to use the correct units of meters per second, hertz, and meters, or it won't work out. Let's tackle an equation to do with the speed of a wave. We've got a water wave that travels with a speed of 1,5 meters per second and a wavelength of 200 centimeters. Now remember, in physics, we never ever work in centimeters. We must work in meters. Remember, there's 100 centimeters in a meter. So if we divide that by 100, that gives 2 meters. When we substitute the given values for wavelength and velocity in the correct units, things work best. Solving for frequency gives us a frequency of 0,75 Hz. Let's look at another question. 5 waves cover a distance of 10 centimeters in 2 seconds. Calculate the speed of the waves. Remember to change the displacement or x into meters before you substitute. Using the equation that has displacement and time, we get a velocity of 0,05 meters per second. It's important to note that if you practice enough, you'll get a better feel for the numbers. This is a very slow wave. I hope that helps with some of the more basic types of wave equations. Remember that wave calculations, like any others, are all about practice.